So let's make a quick sound check. Can everybody hear me loud and clear, or do I need to use a microphone? I probably don't need to use a microphone. I'm a loud person. So, welcome Barcelona to my talk. We're going to talk about scheming. What's scheming? Not the typical English word where you're planning something evil. This is more about scheming things before you do them. Who usually schemes? Architects make schemata for the buildings. Construction engineers change those schemata to be actually viable. Electric engineers make schemata for your electricity in your house, for the cables, etc. All of them write down these things, these schemes, these plans, these things they want to do. And as developers, as software engineers, we shouldn't be much different. So, I'm going to talk about it through this presentation, and I'm also going to have some examples around. We're going to talk about services, which are just a part of everyday programmer work. We're going to speak about them very lightly, so you don't really need to know all these architectural lingo. It's going to be quite technological. We're going to use some specific technology, some specific frameworks for the examples, although principles should apply everywhere. So yeah, who am I? I am Tim. I am a tech lead at kiwi.com. I work with a team of talented engineers to make our product better every day, and we work on booking backend. That is, we mainly connect different services in our backend so everything runs smoothly. A lot of our work is connecting different services, connecting different applications to work together, letting that booking you make get serviced somewhere, get passed to the customer support, get automatically booked, and other following things. This makes it tough. This makes it pretty tough to cooperate between multiple teams. How many of you work in some companies that have more than 5 developers? Could you raise your hands? Quite a bit of you. So it's going to be very useful for you to listen how we do it and how we connect these services to have multiple people work in harmony and have almost no problems with integration. So yeah, I work in Kiwi. You've heard plenty of us already. You heard from Paulina some wonderful information. Basically, what my team does is Python. We work with the Python stack, we work online, we do web development, and we make sure that travel is easier, and we do it by using some technologies around to combine different airlines, etc. You've heard plenty about our product. If you want to know more, we'll be talking later. So yeah, services. They are done by different people. Your colleagues, your bosses, other vendors, depends. All of them get developed by a different group of people. And then communicating these things, how to connect them, can be very problematic. A lot of developers have a problem when they have to integrate some other service, and it usually takes some time. It's trial and error many times, and it gets difficult after a while to just be repeating these same mistakes. So we do that, we solve that by using Schema. We plan it before we do it, and we use technology to actually protect our software from mistakes, from human mistakes. And that's great. It's great when you can protect your product from silly mistakes. Nobody likes making a typo. Nobody likes having work stopped because somebody makes a typo. We try to avoid that. So yeah, I'm going to talk about that, about some examples, some stuff we did at work. I'm going to talk how Schema is great, how it's great to enforce it by software, which makes everybody responsible to follow these rules, or his application just doesn't work. And then they don't make you a headache, they give themselves. Then I'm going to talk about how we focus all that schema in a single place, share it between services, and in the end, how you can do it yourself. I'm going to go through an example where I'm going to make a small, simple application that uses Connexion. That's a Python framework for doing this. I'm going to make a motif of birds. I'm not really versed in them, but it was a nice motif. And it's a made-up example, but the principles should be applicable anyway. At any scale, you can replace the birds with your product of choice. So yeah, let's cover some basics. What's an API? An API is an interface between applications, between services, between code. It's basically just a set of agreed parameters that things change between each other. It's just a part of everyday programming life to connect stuff. You connect them through APIs. What's a schema? Surprisingly, it comes from the Greek word schema, and it's a shape, it's a plan. It's something you figure out and then build upon. So yeah, I'm also going to be advocating for some more planning to determine the schema, determine the objects, determine what you're going to be working with before you start working on it. A lot of people who start out don't do this. They just go along with it. But I'm advocating standing back a step and thinking, hey, we need to have 3 teams working on this. Let's agree before we start coding. So, we're going to do that planning with schema. We're going to write down some data. We'll figure out, okay, we want to have these things work this way. Let's write it down, let's share it between our teams, and let's get it going. Let's have some merry cooperation. You'll get some early reviews from your colleagues. They will tell you that your schema doesn't make sense. That's going to just be great, because you'll figure it out today and not after 2 weeks of coding. Not after the product is supposed to be released. You get it down, you clean out the questions of what am I doing, why am I doing it, and then you can just get to how. You can get to coding. So yeah, it's good to take a step back and start planning. And if you do it with a schema, then you get more code that you can use. So yeah, if you do this schema using technology like OpenAPI, there is also variants like JSON schema and so, but today we're going to be focusing on OpenAPI. You get to formalize your schema. So it's not a plan that somebody drew on a whiteboard, it becomes formal language. And that's great. That's great because then you have this language that anybody can learn and communicate with you in schema. You can have a set of rules that defines, hey, our application will look like that, behave like that, and do these things. And I'll show you an example of an OpenAPI schema in a moment. There are some basic concepts listed here, but it's not so important to figure them out now. They become more important if you try to tackle these things directly. We're also going to cover them in the example. So yeah, we have an example schema for our bird watching application, and it has some metadata defined. Some base path, where is it located? It has some inputs and outputs, what's it going to do. In here, we can communicate with JSON, simplest, definitely easiest to start. We have some definitions, we'll get back to those later. Basically, they are your classes, but in schema language. They are classes you will be using to build objects between your applications. May seem a bit obtuse still, but we'll get there. You also have some info, a contact, so nobody forgets who you are when they use your product. That can get nasty if you make it bad. And we have some descriptions and versioning. Basically, all of this constitutes the meat of your API. It says, okay, we did this, that's how you use it, let's get to the start. This is an example of a path. A path is just a web address you will encounter, a thing you need to use. It's basic internet lingo, it has some status responses, and it uses our schema. So if you access this endpoint on our server, we will return you this object. And you always know what this object will look like. And that's very powerful. It's very powerful that you don't need to poke at it and check it out. You just start working reliably knowing, oh, they're going to return us a bird object. It's always going to have a name, a wingspan, and an additional object, that's the nest. And the nest will always have type and terrain defined. And that's great. You don't have to do a lot of defensive programming because you know that this schema is checked on the server side. You'll get to see how that's done. So yeah, why use this? Why use this restrictive language? Why not just keep the whiteboard on? We are using it because it has a lot of tools. It's very standardized and people have been working with it for a long time. You get an automatically generated UI. That's already a great win. You get to have a lot of resources that people have already compiled. A lot of standard web and other industrial lingo is already covered, so you just copy and paste it. You have a community that talks this, explains this, and you can use it further and further to get some good practices going. You also have a framework we're going to be using, Connexion, which does a lot of the legwork in Python for you. So you don't have to figure out how to validate the schema. It does it for you. It's great. So yeah, we use YAML to write our schema. The previously compiled example was in JSON. It does that internally. Why do we use YAML? It's humanly approachable. We try to get that schema to be a multi-team effort. So we get product managers to write some of it. We get our technical writers to contribute. So it doesn't become something that the devs do. It becomes a whole effort where I don't have a project manager telling me about that one object, but he can read it and read what he needs there. If I tell him that I really need a name to be defined, he can read it himself. He has been talking to me and we agreed that a name has to be defined always. So yeah, it's great to have everybody cooperate with these things because software is not just developer effort. Connexion. It's a framework built on top of Flask. It automatically creates an HTTP server to use these schemata you have defined. It's based on the Open API, and we describe it in YAML. It loads all these things and acts like some kind of a base for what you're developing if you're making a web application. Flask, it's a Python library or micro framework, as they call themselves. It's great. It's very lightweight. It lets you do whatever you want. It doesn't have a lot of opinions. You go, you work with it, you put what you need. If you need a database, you can add it. It doesn't come with it. If you need some special error handling, it doesn't come with it, you can add it. And that allows you great flexibility. That allows you to use it anywhere pretty much. You can add it to any application you already have, and it's just going to work better. It's not going to add a lot of baggage that you have to figure out and compile somehow and fit it all together because it doesn't have a lot of opinions. If you need it to just be there on the side, it's going to work like that. Together, they make this very flexible, very smart way to approach problems because you can add the schemata to an existing project and it's going to work great. It doesn't add a lot of bloat, it doesn't add a lot of opinions, you just use what you have and extend on it. And that's great. Its simplicity allows you to hack it as far as you want and you can do a lot of things very fast. So yeah, this tooling enforces your schema. It makes you responsible that what you've written there, that your documentation always evolves. How many of you have had problems when they read a thing in the documentation and then tried out the software and it didn't work out at all? How many of you have been misguided like that? Could you raise your hands? Oh, almost everyone. It's a classic. It's a classic. You read that this should return that, and then you try using it and everything breaks. Why? Because somebody made an undocumented change and everybody has a headache now. Your whole plan got wrecked. How to fix this is to make that documentation in your code. Your code compiles from that documentation, from that schema. It actually creates a zone that validates all inputs and outputs, so you know that if you break your own contract, it's not going to get released, it gets broken. So any basic test will break. You don't even need to have a lot of tests. Just several simple pings will break the whole application if you break the schema, which is great. You don't release it, you go back to the drawing board, you fix it. It lets you know with reliability that you will not break your clients. And that's great. If you've ever done a service, that's an amazingly great thing to have. Because you will not get called at 2 a.m. by an angry client demanding you pay out everything you've broken. Happens. So yeah, if you enforce it, you can forget about having it outdated, as the software will make sure it works, it stays up to date. Humans make errors, machines rarely do. So yeah, this is an example of the setup of our framework. We'll have some common code that's pretty unimportant for the point. We'll have a schema module that will have all these parts of the schemata in itself. Then we'll have our two applications, keepers and watchers. One of them will have, this is one, both are very similar. It will have some handlers, that's the code we write, and it will have some extensions to the schema, and also the defined application. It's pretty basic, but it serves to prove the example. So yeah, this is some code. There's a constant list of birds instead of a database. There's some methods here. These methods are very simple, and that's by design. You don't have to do any checks because the schema will validate that the bird name is always defined, that it's always of a certain length, and that it fits your standards. If it can only be alphanumeric characters, you don't have to worry that it will break your methods because it's now some rubbish. It doesn't allow rubbish to pass. So you can write very naive code because you know that the validation has already been performed, and you don't have to bother writing for the millionth time and worrying about length of strings and characters in strings and if something is defined, if it isn't. It's all in the package. And you already defined it, you've already talked about it, and you don't need to repeat yourself. And that's great. And what's even better is that if you share this schema between multiple partners, they all have the same rules. They will all validate the same logic. So there will be no misunderstandings where somebody takes a number as a number and the other person takes it as a string. That can cause headaches. This way it won't really happen. So yeah, I jumped ahead a bit. That's the reason for sharing the schema, to have it between the teams as a module rather than a thing everybody codes from a whiteboard. And it, bundled with this great package, it allows you many wonderful things. And it's a contract. It's a contract that all of you follow and that you don't break without important reason. It lets you step back and say, oh, I would need to break 3 applications to make this change. Is it worth it? Sometimes it is, sometimes it isn't. So, there are multiple approaches to execute this. We have it with some formatting guidelines at Kiwi. By the way, this repo is public. It will be shared at the end of the presentation, so no worries. You don't have to write down stuff. So yeah, it will bundle several schema files together from our module to get this coherent product to build. And then, with it bundled, we get the same schema our colleagues do. This is not great in connection. Unfortunately, it's not yet there fully, so you may have to add some of your own code depending on how you decide to implement it. But versions are coming out rapidly, and a full link expansion, something like the modules in Python, should be available very soon. And when it does, it will be a perfect approach to solve this problem. So yeah, well, there's a problem. Moment. Okay, so yeah, another example. This is a bird object. It has a name, a wingspan, and a nest, like I've mentioned. You can look at it a bit. It also has some things defined, like the length, type. It's a cool thing to describe the project with. By using this object in all your applications, you ensure that this is constant, consistent. Everybody will use the same type of a name, and it will always have all this documentation following it. You also define some examples. These examples are used by your tools to automatically populate your examples. So you don't have to worry about writing examples for your colleagues. They automatically get generated. That's very nifty. You don't have to make up stuff all the time. It gets baked in. So yeah, this is a bit more a less similar example. There's a tag on the top. We share tags as well because we want our products to be tagged the same way. So when a person in one team is talking about baggage as a keyword, capital B baggage, all of them will have this tag with their own endpoints. So all of them are sharing the same idea, the same lingo. And having the same lingo saves a lot of time when somebody doesn't have to ask, what is this, several times to several different people. So yeah, the future of this schema sharing, as I mentioned, is rapidly getting there. You have the tools to do it right now, asynchronously. We do it in code. We do it before we start the application. So we've chosen that approach as an easy way out. I would also suggest looking at Specky, which would handle all of these problems because it builds a file and it also links it, which is great. You get to check if your ideas align with what people consider standards of the industry. If you're exposing some part of your object with underscores, it will usually lint it and say, hey, maybe you don't want to show your privates to the world. Maybe that's not a good idea. And you can check, ignore it, or abide it. It's a pretty good thing to have. That's what I mentioned. That's what I thought and said when I mentioned tooling. There's a lot of these nifty tools that help you validate your ideas that they make sense. So, after all this was mentioned and shown, let's talk about the product we will simulate. We'll have multiple services talking together. One of them, a register of birds, where you have a list of all kinds of different birds. The other one will be something like a service for saying, okay, I own this specific bird. They're both going to be a part of your system. One is going to be the store of data or a search, some kind of a search. The other one will be a part of your registry, some kind of booking almost. So yeah, they will be integrated together, so when one offers you a bird, you can just send that bird on to the next service, and you will know that it's valid, that you don't have to make any changes if you don't mean to. And that's great. That lets you know that if you have an example in the point A, that example is valid for the point B, and it ensures it programmatically, so you don't have confused clients. So yeah, let's get to the example. This is the generated UI from Swagger. It shows the examples of the two applications, the bird keepers and the bird watchers, and they have their endpoints shown here. It's pretty dynamic, so when you click one of the endpoints, it shows you an example of what it returns. It shows you how it's going to look, and it's perfectly copyable. So let's do that. Let's copy it and try it out. And if you post it here, you know that it's going to work out. You send it, the logic happens, and if you remove the name for some reason, it will fail. It will return you a 400 error, and you never wrote a line of code to assure that happens. And the UI also allows you to play with these things, to test out the API on any way you want it to be, and that also works wonders. So yeah, the conclusion is to have this schema as your documentation, as your project, and to talk about it before you start coding. And after everybody agrees on it, and you hopefully get a project manager or two to start contributing, you get to have that product forced. It forces everybody to align with the same idea. You reuse it, you don't repeat yourself, defining the same thing multiple times. It's all defined in the same central repo. You use the same terminology. Everybody knows what a bird object is. If you have it defined like this, you cannot have a member of a vendor team redefine it to have their own idea. No, they don't get to. They're using the same library everybody else is. And having this tight interface just pays for itself so many times over. You don't have people conflicting, you don't have arguments that somebody wants something done his way for whatever reason, because they know they would have to push it upstream and to have it in the central schema. And if it's a good idea, you want it there. If it's not, you get a lot of people who can express their opinions. So yeah, how to start using this? Basically, try it out. Try out these tools, see if they work for you, see if your team can use something like this. If you can connect one or several applications together, it's great. And the thing is, by default, all the Swagger schema get exposed and are reachable by other applications. So if you have your server running and it hosts a Swagger schema, an open API schema, you can connect to it with a different application and just load the symbols from it. So you load the objects from it and then work with them. Validate internally. You don't have to hit their API. You get to share it directly. So yeah, try it. Try to make it a process. And even if you have some nonsense right now that just doesn't lend itself to you reverse engineering it and figuring out all this schema, there's this great article from Phil Sturgeon that lets you approach the problem programmatically and use these tools to reverse engineer the schema. It looks through your logs and things like that, and you can get the schema for free if you have an already running production application. And that's also great. That lets you jumpstart the whole process without having to read through all the existing documentation that's probably outdated. So yeah, these are some resources, as well as the repo that I mentioned, some keywords that I've been talking about, if you want to search about it, figure it out, and some useful links, some useful articles that can help you educate yourself more on the API design. It's a lot of cool resources. There's a whole world of it out there that will let you figure out, hey, maybe we should cooperate without actually using whiteboards. And that would be a beautiful world. Thank you for your attention, and let's continue with the questions. So, any questions? Sure.
Do you have any experience on how connection works about versioning?
Yeah. Probably people heard you. Could you repeat, please?
Do you have any experience about with connection about versioning? Because it's the same.
Versioning?
Yeah.
It doesn't support versioning. They also suggest that versioning is usually a bad idea, and it is. If you version your APIs too much, you end up with a lot of spaghetti code. But they promote, and here one of the links, the Zalando one, talks about it as well. Usually you want your API to be growing. So you want your schema to always grow, and deprecation should be a rare case. But if it does happen, you have tools to version your API as well. It does have version tags, and several approaches are there to implement it. OpenAPI has support for it, even if it doesn't recommend it. Next. Anyone? Sure.
There's a question. What happens if you break your own schema? That you output some number that are some bigger than
You can configure it. Let's say we decide that the wingspan should be words now, should be large, small, medium, and we code that in, but we already have a couple of clients and they do some number magic on it, we would break it if we had a normal API. But if you have connection in place, you can set it up to have a fatal error or just a warning, externally worded warning, that would say, hey, you're breaking the schema. This will not work. Your clients will fail. And that's great, because then you would have to update the schema itself. So you would go push it upstream, and all the clients would get the same update. So in this case, it's very important to actually check it and comply with the steps, because then you have to notify all your clients, and you cannot make eager mistake unintentionally. So basically, you define how strict it is. For us, we have several tests running just random hits on the API. Not random, they hit every single endpoint. But if you change the schema, that test automatically fails because the schema fails. It doesn't let you return, it just throws a 500. You can define it to just war, but then you're losing some of the big advantages that it gives. Thank you.
Question?
Sure.
Is there any way to generate client-side code from OpenAPI schema?
Yes, you can hit the public swagger.json with your app, and there are tools. I think JavaScript has some great tools that create models from those defined schemata objects. Basically, it goes through the schema and defines the object itself. There are static tools, definitely, that build this previously, but there are also dynamic. There's a lot of tooling around. Thank you very much once more.